Hi, this is Darshan Santha and welcome to this example video for the chain rule. So like I said in my previous video on the chain rule, which you should check out if you haven't seen already by the way, this video is just to sort of help you solidify what we learned in that video. So I felt that adding these examples to that video would make the video too long, and also I wanted to give these examples a little bit more thought so that we can really nail them into your head. Alright, so let's go ahead and get started. So for example number 1, y equals 5x plus 3 to the 34th. So this is a kind of typical example of where chain rule would really come in handy, right? So if you had to FOIL that all out to use power rule, that would be a nightmare. So instead you could use the chain rule and you could get it done with in one swift step. So again, we have to the key thing to do is identify your two functions of x, right? This may not always be clear, but that's what we did at the exercise at the beginning of the previous video, where we identified the different functions of x. So what is the outermost function here, right? What encompasses everything, right? Well, that would be the 34th power here, right? So the outermost function, all right? So the outermost function here would really be x to the 34th. Because the 34th power is everything inside here is being raised to the 34th power, so that would be the outermost function. Now what about the second function? The inner function therefore would be what's left, because we only have two functions. That would just be 5x plus 3, right? So this is the outermost function and that's the innermost function. Okay, so now we've laid that down, let's go ahead and use the chain rule. So the chain rule is the derivative of the outer function of f of g of x, the derivative of f of g of x, so that's the outer function with the inner function inside, times the derivative of g of x, or the inner function. So therefore what this is going to be is, so y prime is going to equal the derivative of everything of the outermost function. So this would be the derivative of this, but with that plugged inside. So this would be 34 5x plus 3 to the 33rd, right? Times the derivative of 5x to plus 3, which is just going to be 5. And now some cleaning up would just yield that this is 5 times 34, which is going to be 170 5x plus 3 to the 33rd. And that would be your final answer. It's not worth simplifying this any further. Right, so that's how you do that. The second one, right, this actually has multiple functions of x. Let's go ahead and identify all of them. So number 1, we have the all-encompassing function, which is going to be e to the x, right, because everything is sort of plugged into e to the x. Number 2, we'd have the second most inner function, which is going to be the sine of x, right? And last but not least, we have the function that's inside that, which is going to be 2x. So we've got 1, 2, 3 functions. And again, the chain rule is not just restricted to 2 functions. You can use it for as many composite functions as you need. So therefore, what we're going to do is we're going to take the derivative of that with everything plugged in, then the derivative of that with everything plugged into that, and then the derivative of that. Okay? So let's go ahead and do that. So firstly, what's the derivative of e to the x? Just by itself, it's just e to the x, right? So this would be the y prime would equal e to the sine of 2x, just e to the sine of 2x, right? Because the derivative of e to the x is e to the x, so the derivative of that would start with this expression, times, what's the derivative of sine of x? Well, that's just going to be cosine of x. But we got to keep in mind that because we have the 2x inside, we got to make sure we have the 2x in here as well. And then what's the derivative of 2x? Or the innermost function? Well, that's going to be 2. Right? So that's what this would be. And then just putting everything together would yield 2 e to the sine of 2x times the cosine of 2x. Right? So that would be your derivative to this example here. Right? Again, it's just important to identify each of your functions, then identify what's going into what, and then sort of just lay out the expressions, okay? So that's that for these examples. Let's move on to our next two. Alright, so these are the final examples of this video. So the first one is y equals the natural log of secant of x. Alright, so again, we just identify what the functions are. So the first one is ln of x, and the second one is secant of x. Right? So now we just go ahead and do what we've always been doing, derivative of the outermost function, and then times the derivative of the inner. So this would be y prime equals 1 over secant of x. And then, do you remember what the derivative of secant of x is? Well, it's secant of x tangent of x, which is something you should have memorized all the way, by the way. And now, from this case, it's just a matter of cleaning up, and the secant of x and the secant of x cancel out, so you're actually just left with tangent of x. Right? So that would be your final answer. And on just a random side note, that expression right here is actually the expression for the integral of tangent of x. So once you proceed into higher levels of integral calculus, you'll actually learn how to derive that using something called u substitution. And so that's just a random side note here, but for now it's really of no significance. So last but not least, this is one that's going to be a little bit more challenging because it might take a little bit of rearranging to see what's going on here. So let's go ahead and rearrange this function, right? So again, 1 over something just means you're raising something to the negative first power, right? And whenever you have a fraction, that means you're raising it to the 1/2 power. So putting these two together, this really means, this is just really y equals 5 minus x to the negative 1/2. Okay, so now let's identify our functions of x. Number one, we have the all-encompassing negative 1/2. So our first function would equal x to the negative 1/2, and our second function would equal 5 minus x. Right, so those are our two functions. So that's pretty easy to identify. And now let's just go ahead and do what we've always done, take the derivatives. So y prime of x, or y prime, would equal negative 1/2 of 5 minus x. Remember, we subtract 1, so this would be negative 3/2 times the derivative of 5 minus x. It's going to be negative 1, not just 1, but it's going to be negative 1. Right, so this would be negative 1, because again it's negative x over there. So just putting all this together, this would be the negative 1. The negatives here would just cancel out, so you'd have 1/2 5 minus x to the negative 3/2 as your final answer. Alright, so that's how you do it. Again, I just hope you saw the processes here. The idea, you plug in, you take the derivative of the outer function, then the inner function. So that's, I hope you just got this process here. In the future, these problems will be gone through a lot quicker, both in your classroom and in my video series. But I just hope this helped you get a clear picture of what we're doing here, and hopefully helped you understand these concepts better and just made you more comfortable with the chain rule in general. So that said, that will be the end of this video. Thank you so much for watching. I hope it helped you out. Please do like and share if it helped you, and leave a comment if you have any constructive feedback, or if this video really helped you. And last but not least, please do subscribe. It really means a lot to me, and also you can just check out whenever new videos come out. So that's it. Thank you so much. I hope you have a great day.